Hi, this is Mr. Lyons. In section 10.2 we're going to take a look at parabolas. I'm going to make three videos to match these three objectives here. So let's look at the first objective, analyzing parabolas with the vertex at the origin. So here we can see the definition of a parabola. And the way that they've defined it here is they're basically showing us that a parabola is a set of points that is equidistant from a point called the focus, and a line called the directrix. So these two segments are congruent, if you will. Every point on that parabola will meet that definition. So for instance, if I select another point here that's closer to the vertex of the parabola, I could go ahead and draw in the two segments. One that goes from the point to focus, another that goes from the point and is perpendicular to the directrix. And you'll note that this segment and this segment are equidistant or congruent. So let's take a look or analyze a parabola where its vertex is at the origin. So here we've shown that same definition that we just talked about. We have a set of points that's equidistant from a point called the focus. Focus is actually on the x-axis in this case. The vertex is at the origin, as I said, and then the directrix is equidistant from the point. So we can see here again that this segment and this segment are congruent. That mark in there. A parabola that's in this orientation has an equation which is y squared is equal to 4a times x. And if you remember that we talked about library curves back in our chapters about functions, this actually ends up to be the square root function, which would mean that we'd have to either do the positive square root or the negative square root for it to be a function. The whole parabola in this horizontal orientation is not a function because it does not pass the vertical line test. So what does this new variable called a mean? What is that? Let's take a deeper look at this. So let's take a look at it with this example. Find an equation of a parabola with the vertex at origin and the focus at 4, 0. So we're going to analyze that using this basic equation format. Y squared is equal to 4 times a times x. So first let's put our givens on our graph here. So we have our focus is at 0, 0. I'm sorry, our vertex is at 0, 0. So I'm going to place a point there. And then also we have a focus which is at 4, 0. So we have our focus here. We'll go ahead and label that with F. Let's make that. Okay, and so that is 4, 0. And then our vertex is at the origin. Now this variable a is actually the distance from the vertex to the origin. So I'm just going to label the length of that segment a. And that distance a is also the distance that goes from the point on the parabola, remember, to the directrix. So our directrix is actually going to be a line at x equals -4. I'm going to go ahead and dash that in here. This is x equals -4. So what would our equation look like then? If a is equal to 4, well, we have y squared is equal to 4ax, as we said. That's the basic format, or the standard format here in the vertex form. And then we're going to put in our a, which is 4. And so y squared then equals 16x is the equation of our parabola. Now, in order to graph this parabola, we need to find some more points besides the vertex on the parabola. So we're going to plug in some x's here to find some y's, some ordered pairs that we can use for points, other points on the parabola. I'm going to suggest that we actually just plug in x equals 4 here, which would coincide with the x coordinate for the focus. So we're going to have y squared is equal to 16 times 4, which is 64. And so our y's that are going to go with that x of 4 are going to be plus or minus 8. And so we're going to go ahead and plot those points. So 4, positive 8 would be up here. 4, negative 8 down here. And then we can go ahead and graph our parabola through those points. Now there's actually a special name for this segment that connects these points on the parabola that goes through the focus. And this segment's called the lattice rectum of the parabola. The lattice rectum is actually a plus or minus 2a. From the focus. Alright, in the next video we're going to look at the equations for other parabolas where their vertex is at the origin. See you then.